In homework 1.7b, the first page, the hardest thing is to figure out what part is a power rule and what part is just a constant. In this first one, we've got x to the 5/4 times the square root of 5. The power rule is when you have x to the n power. That's going on right here. Square root of 5 is not a power rule because it's not x to a power. This is just a constant. It's the same as if it was like 2 times x to the 5/4. And so when we do the power rule, it's 5/4. I need to label correctly here. Don't just start doing things. This is f prime of x. As soon as you do the power rule, you have done the derivative, so it's 5/4 x to the, well, the power is going to go down by 1, so it's 5/4 minus 1. And I need to get a common denominator. 1 can be rewritten as 4/4. 5/4 minus 4/4 is 1/4. So this is x to the 1/4 power. Times the square root of 5. I can rewrite my fraction exponents. This is going to be 5/4. I'm going to reorder 2 to put the square root of 5 here. 5/4 square root of 5 times the 4th root of x. Remember that the denominator in an exponent tells you what root you do. The numerator tells you what power x is to. So, looking forwards, some kids will try to do the power rule on ones like number 5. They'll rewrite it as 5 to the 1/2 power and try to start like multiplying by 1/2 and stuff like that. No, this is a constant. The square root of 5 is 2.23 something 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 something. The derivative of a constant is always 0 if it's not multiplying by a variable. We'll do one more on this page. Let's go to number 12. Number 12 has negative 2 over 5x to the 4th. So the trick is to rewrite this using, so we can use the power rule. I have not done the power rule when I'm rewriting it, so I'm going to still call this f of x. The constant is 2/5. This can be written as x to the negative 4th power. Because we're dividing, that's a negative exponent, and the coefficient's just going to be out in front. So the power rule says we multiply by the power. This is now the derivative because we are doing the power rule. When you multiply a whole number times a fraction, negative 4 times negative 2/5, remember that you can take the whole number and change it into a fraction, and the whole number always ends up just multiplying times the numerator only. So the shortcut way is you just multiply the whole number times the numerator. Negative times a negative is a positive, 8/5. X to the, this power needs to go down by 1. Negative 4 minus 1 is negative 5. And I cannot leave this written with negative or fraction exponents. So I'm going to rewrite f prime of x as 8. X is going to move down to the denominator because it's to the negative 5th power. The 5 is also in the denominator. 8 over 5x to the 5th is the correct way to write it at the end. On the back, it's got slightly different instructions. First it says, find the derivative of the function at the given value. Well, the derivative, to find the derivative of the function at the given value, we need to first find the derivative, and we're going to use rules. So I'm going to rewrite this so it's clearly a constant. It's 1/2 x squared minus 4 times x plus 3. And to find the derivative, I'm going to use the power rule. It's going to be multiply by the power. 1/2 times 2 is 1. The power goes down by 1. X to the 1 power is just x. 2 times 1/2 is 1. I don't need to write 1x. 1x is just x. Here, this is x to the 1 power. We multiply by 1. It's going to be 4 still, and the power goes down by 1. It's x to the 0th power. X to the 0 is 1. So it's 4 times x to the 0. 4 times 1 is 4. Or you can just remember that anytime you take the derivative of a number times x, it's just that number. The derivative of a constant is 0. So this is the derivative. We have not answered the question yet. It wants to know the value of the derivative when x equals 2. So we're going to put evaluated at x equals 2. We do this because it's not f of x equals, so we can't just put f prime of 2. We have to put evaluated at x equals 2. And this will be 2 minus 4, which is negative 2. So y prime evaluated at x equals negative 2, at x equals 2 is negative 2. Let's do one more type. We'll do this one. It says, find the equation of the line normal to the function at the given point. Another word for normal, it's like a perpendicular. It's perpendicular to the tangent line. So the normal line will also intersect at the point where the tangent line would, but the slope will be different. Normal lines kind of bash into a function at a right angle. So to be able to find the slope of the normal line, we're actually first going to find the slope of the tangent line. The slope of the tangent line is the derivative. So what we're going to do is we're going to find y prime, and it's 3x squared, that's the power rule, minus 2 times 3 is 6, lower the power by 1, it'll just be x. The derivative of the constant is 0, and we're going to evaluate this at the point. The point is when x equals 3. So the x value will plug into the derivative, and this tells me the derivative evaluated at x equals 3 is equal to 3 times 3 times 3 is 27, minus 6 times 3 is 18, 27 minus 18 is 9. This is the slope of the tangent line. So the tangent line slope is 9. That means the normal line, which is perpendicular to it, the normal line has a slope of -1/9. Remember to find the slope of a perpendicular line, it's the negative reciprocal. So the equation is y equals the slope times x minus x1. We're looking for it at this point, plus y1. This is our equation of the normal line. You really want to make sure you've memorized by now y equals m times x minus x1 plus y1. This is the equation for any line. The slope of the normal line is right here. The x value of the normal line is right here. And the y value is right here. I hope that helps.